This is the class ABC system. It can work, but there are some shortcomings. What's the shortcomings? For example, the class A, the network part is the 8-bit, okay? So the host part is the 24-bit. 24-bit for host. So how many IP address can contain 2 powers 24? Yeah, this is a bigger number. Okay, this is a bigger number, about 16 million. 16 million. I think no network can contain so many hosts in one network segment. Okay, and of course the class B also the network mask is 16. So how many hosts can contain 2 power 16? So about 64 kilo. Okay, 64 kilo hosts in one network. That's still too many hosts. Okay, so this is an example. That's one in such network. One network contains 30 hosts. Of course, the smallest one, class C, can contain 264 hosts. Okay, that's still too many IP addresses. If we use class C, then about 200 IP address is wasted, not used. So how can we solve this problem? We have used the mask of 8, use the mask of 16, use the mask of 24. If we can use other masks such as 20, such as 27 and 28 and so on, can we use this? Okay, this is a question. Okay, so we developed another system we called VLSM. Yeah, variable length subnet mask. That means the mask length is not fixed. It's not fixed to 8, 16, and 24. Okay, the network mask can be variable. Okay, here you can see this is the network address. Okay, and then this is the subnet mask. This subnet mask is different from the class A, class B, and class C. That's a 255, 255, and 255. And then this is not 0. This is 128. We can see 128 represents the first one, and then others 7 is 0. Then we can see in this mask the 25 are a sequence of ones, and then the 7 are 0. Okay, that means the 25 bit in this 32 bit are network part, and the 7 bit are host part. And then we can see the network part is the network address is 192.168.1, and here the host part are all 0, and then the first bit network part are all 0, are still 0, are also 0. So the network part is 0. And then how many hosts can contain in the host in this network? That's the 7 bit. Okay, then 2 power 7. 2 power 7 is the 128. Okay, of course, the varied host. That means this address includes a 0 and the ones, all zeros. All zeros represent the network address and all ones represent the broadcast address. So minus 2. Then this is the varied IP address can be used in this network. Yeah, it's the 126. Okay. Then this is the case. How to calculate the VLSM? Then we just calculate it. There's 30. Okay, in the first network, there's 30 hosts. 30 hosts. We first calculate 2 powers n should be greater than or equal to 30 hosts, because in the network there's 2 IP addresses cannot be used, all 0 and all ones. So this is 32. 32 just equals 2 powers 5. That means in the 32 IP address, there's 5 bits. 5 bits should reserve for the host part, and then the other 27, okay, 27 bits can use for the network. Okay, 27 plus 5 just equal 32. Okay, equals 32. Okay, so the IP address, the network mask should be 27 length. Okay, the length should be 27. Of course, the value should be 255.255.255. Then 27 means what? 224. Okay, 224. 27 means 111, then 50. Okay, this is a binary value. If you calculate it, just equals 224. Okay, and then we calculate another. And another network contains 20 hosts. 20 hosts, you calculate 2 powers n should be greater than or equal to 20 hosts plus 2. Okay, that's a 22. That's 22. Okay, if you n equals 4, that's the 16. That's smaller than 22. If it's 5, it's 32. Then greater equal 22. Okay, and then if it's 32, okay, just equal the first case. There's contain 30 hosts. Okay, so the mask of these two networks should be the same. And then if they are contain 10 hosts, so also we calculate as this: 2n is greater than or equal 10 plus 2. Okay, to reserve the IP address. That's a 20. That's a 12. And then n should equal 4. Okay, then in this 32 IP address, the 4 should be reserved for host part. So there's 28 bits used for network. So the mask length should be 28. Then we can calculate the mask should be 255, 255, and 255. That's the 24 bit. And then the last bit, that's the 1, 1, 1, 1, and then 0, 0, 0, 0. We can calculate the binary, then that equals 2, 4, 0. Okay, you can practice this. Okay, this is how to calculate the VLSM. Okay, and then another concept of the classless inter-domain routing. There's the abbreviation. That's the CIDR. What's the CIDR? Yeah, when we use the class A, class B, class C address, then the route sending by the router always have the mask length of the 8, of the 16, of the 24. But now we use the VLSM. Okay, the mask length is not always equal to 3 values. So the router should send in route of different mask length. Maybe sometimes that's 27, sometimes that's 20, that's 20. Okay, for example, in here, in this scenario, there's 4 networks. Of course, the first 2 bytes is the same. Of course, the last, of course, is the host part. Of course, when we use a network address, it's always 0. But the third byte is different. 0 means 0, 0, 0, 0, and then 0, 0, 0, 0. And then 1 means 0, 0, 0, 0, and 0, 0, 0, 1. And the 2 means 4, 0, and then 0, 0, 1, 0. And then 3 means 0, 0, 0, 0, and 0, 0, 1, 1. Okay, we can see the third byte, the first 6 bits is the same, our 0, and the only last 2 bits are different. Then we can summarize. Sending 1 network mask, that means there's 16 bits is the same, and then additional 6 bits is the same, our zeros, and then others is different. So we use this 16 plus 6, that means 22. The first 22 bits are 10, 24, and then 0, and then the rest 10 bits include the last host part and the 2 bits in the network part. That's variable. Okay, so in here, this router sending out a route, 1 route, that's value is equal this. The mask length is 22. Okay, this is the CIDR. The CIDR can make a routing table small. Okay, the 4 routes, 4 networks, then only sending out 1 route item. Okay, this is CIDR.